let's start recording now. Okay, so we're going to go into part 2 of the module on diodes, and this is practical diode applications. We're going to actually discuss only 2 types of diode circuits. One is the rectifier and the other is the clipper or the limiter. Ang inputs nitong mga circuits na to are assumed to be non-time varying. The input of a rectifier and the input of a clipper or a limiter, assumption is these are time varying. No? These are time varying inputs. And for purpose of illustration, we're going to assume that the inputs are AC input voltages. Okay, but that does not mean that is the only type of situation that you will encounter in this course. You might encounter different types of input voltages, and you should be able to solve for what the output is going to look like. So the first circuit that we're going to take up is the half-wave rectifier. And we're going to analyze this on the basis of the ideal diode model. Okay. So how do we know when the diode is conducting? We have 2 techniques. One is to assume it is conducting, to replace it with its equivalent model, okay, and then determine what the direction of the current will be. Okay. So if I assume, no, first of all, it's an ideal diode siya. I assume it is conducting. So I replace it with its model. So what will the model look like? It will be a short circuit. Kung ideal diode, remember, ideal diode to. Okay, so this is V out. This is R. And this is the shape of V in. Okay. Notice that during the positive half cycle, so we can classify the input voltage in terms of half cycles. This is one complete cycle. This is one cycle. And this is one half cycle. This is a half cycle. Okay, so you have positive half cycles. These are the positive half cycles. And you have negative half cycles. These are the negative half cycles. So take note that during the positive half cycle, current tends to flow in the clockwise direction. So positive half cycles, okay, I is clockwise. Meaning to say, current is flowing from the anode to the cathode. And therefore, during the positive half cycles, this is the correct equivalent circuit. Okay. Now, what is V out? What is V out? Note that V out is just equal to V in. So if I were to draw V out, let me draw V out here. No? Ang V out ko will be equal to V in. So let's assume the red is now my V out. No? This is now V out. Now what happens during the negative half cycle? During the negative half cycle, ano yung nagiging direction ng current? No? It becomes counterclockwise kasi ang input voltage natin ngayon is negative. No? Our input voltage is negative, so we're going to get a negative value of I, or the actual direction of current will be in the counterclockwise direction. So negative half cycle, I is counterclockwise. So kung counterclockwise, ibig sabihin nun, mali yung assumption natin. So this is a wrong assumption. The correct equivalent circuit will be like this. Dapat open circuit siya. V in plus minus V out. So in this case, what is the value of V out? Anong value ng V out dito sa case na to? Can I hear a shout out? Anyone?
0.
Correct, 0. No? Bakit 0? Bakit 0? Dahil wala kang current. 0 yung current. Kung 0 yung current, ibig sabihin yung voltage drop across your resistor will be 0. So what will our output look like? 0. Okay. So this is now going to be what our output will look like. Pag positive half cycle, it just replicates the input. Pag negative half cycle, it is just 0. And you call this a half-wave rectifier. What is a rectifier? A rectifier is a circuit that converts AC to DC. Kung naalala nyo yung definition ng AC, AC is a signal whose current changes direction in a periodic manner. Yung current or yung voltage polarity, if you'd like to think of it that way, either the current changes direction in a periodic manner or the voltage polarity changes from positive to negative in a periodic manner. So itong voltage na to, sometimes it's positive, sometimes it's negative, no? And periodic siya, periodic. Therefore, you consider that to be AC. Pero pag tinignan mo yung pula, hindi nagbabago yung polarity. Or rather, hindi nagbabago yung sign, no? Hindi nagbabago yung sign ng polarity or the direction of the polarity. Ang nagbabago lang is yung value ng voltage. And strictly speaking, that is DC. If the sign of the polarity does not change, if it stays positive or if it stays negative, strictly speaking, you classify that as DC. Except that it is not a steady DC value. It is a time-varying DC value. So itong pula, it is DC, but it is a time-varying DC value. If you remember at the start of the course, sabi ko, pag sinabing basta't sinabing DC lang, ang assumption natin it is a steady DC. Okay? But that does not mean that this is not DC. This is also DC. So are there any questions with respect to this example? Any questions with respect to this example? Actually, there's text that accompanies this, so pero hindi ko na lang buburahin yung ano ko, no? Yung annotations ko. Okay. Let's assume that we are using the constant voltage drop model, no? So kanina, ang ginamit natin is yung ideal model. Ngayon gamitin natin yung constant voltage drop model. Okay, this time, let's try to determine, so baguhin natin yung approach natin dito sa problem ngayon. Ano? Let's try to determine under what conditions will the diode conduct. And we're going to do that by first assuming that the diode is not conducting or equivalent to an open circuit. So how do we know if the diode is conducting or not? So kunin natin yung open circuit voltage. Okay, so let's call this plus minus. Let me just call this V sub D. No? Kahit na hindi nakakabit yung diode, let me call that V sub D. Open circuit voltage. Okay, what is the value of V sub D? Can somebody shout it out to me? Ano magiging value ng V sub D? open circuit to? Anyone?
V in po, sir?
Yes, that's right. No? The value is V in. Why? Your current is equal to 0, and therefore, there is no voltage drop across your resistor. No? So kung mag-KVL ako dito, I'm going to get V sub D plus 0 minus V sub in is equal to 0, or V sub D is equal to V in. And you can also see very well, no? So this is the voltage drop here is equal to 0. So itong terminal na to, the potential here will be equal to the potential there. Parang nakaparallel yung V sub D at saka V sub in. No? So VD is equal to V sub in. Okay, VD is your open circuit voltage. When will the diode conduct? When will the diode conduct? Your diode will conduct when VD is greater than or equal to V sub F, or V in is greater than or equal to V sub F. Yun yung second method. No? Naalala niyo yung second method? How do you know the diode is conducting when V in is greater than, when the open circuit voltage is greater than the forward voltage of the diode? It will not be conducting if the open circuit voltage is less, no, is less than the forward voltage of the diode. Okay, so under these conditions, what is the equivalent circuit? Okay, so this is conducts, no? So the conducts when V in is greater than or equal to V sub F. So what is the equivalent circuit? Your equivalent circuit, V in, you now have your constant voltage drop model, V sub F, okay, and this is now V out. So what is the value of V out? Anyone? No? I just want you to participate. So please, anyone, what is the value of V out?
Sir, V in minus VF.
Correct, no? V out is just V in minus V sub F. Okay? So, tignan natin yung input natin, no? Ito yung input natin. Okay? Kunwari, ito yung value ng V sub F. Okay? Kunwari, yan yung value ng V sub F. So, this is V in. This is V sub F. So, when does the diode conduct? No? The diode conducts when V in is greater than V sub F. In other words, the diode conducts starting from this point all the way to this point. No? From this point to this point, the diode is conducting. So let me indicate that here. So from here to here, it conducts. And what is your output? Your output is this curve, okay, minus a constant which is V sub F. Yan yung equation na to eh, V in minus V sub F. No? Your output is this curve minus a constant equal to V sub F. So what are you actually doing? No? Yung curve natin, binababa natin by a value equal to V sub F. We're translating it downward by a value V sub F. So what does our output now look like? It's going to look like this. So this is V out, which is V in minus V sub F. Okay. I hope everybody sees that. No? Okay, when does it not conduct? not conduct when, no? When the open circuit voltage is less than V sub F. Or V in is less than V sub F because VD is equal to V in. So this is when V in is less than V sub F. And what is our output? No? Pag not conducting, if it is not conducting, ito yung equivalent circuit natin. Eksakto. Pag not conducting, di ba? Dahil open circuit siya. In other words, we validated that it is an open circuit. So what is our output? V out is just equal to 0. Right? Because you have no voltage drop across your resistor. So what will your output look like? It will be like that. That's everywhere else. So ganyan yung magiging output natin. Okay. That is the constant voltage drop model, using the constant voltage drop model in a half-wave rectifier. No? So the difference between this and this is also V sub F. Because remember, we shifted the curve down by V sub F. Okay. If you try to do a simulation, you're going to see this. And if you make the input voltage very large, kunwari, no? 220 volts, ano ba naman yung 0.7 ng silicon compared to 220? Ang makikita nyo, halos dikit na dikit yung red curve at saka yung blue curve. Pag malaking-malaki yung Vin. Pero kung maliit yung Vin, kunwari yung Vin natin, yung amplitude ng Vin natin is only, let's say, 2 volts. Yung 0.7 volts now is significant compared to 2 volts. Makikita nyo yung separation talaga between Vin and Vout. So that's your constant voltage drop model. Are there any questions so far?
Sir, what happens to the energy when the diode is not conducting? The energy
What?
from the alternating current source.
From the source?
Yes.
Yeah. You should be able to answer that. Ano? What is your current when the diode is not conducting?
It would be 0.
0, right? And what is power? Power is voltage times current. So that's going to be 0. In other words, your source is not going to be delivering any power. No? So there's going to be no energy.
Okay.
Okay. Yeah. No, but anyway, I appreciate the question. No? Those are good questions. Okay, any other question? Okay, so this is just an explanation of what I already said. No? So in effect, this is the equivalent circuit when V in is greater than or equal to V sub F. Ito yung equivalent circuit natin. And V out is V in minus V sub F. This is the equivalent circuit when V in is less than V sub F. V out is equal to 0. So now this is your plot of V in, V out versus V in. Okay. Now let's go to a full wave rectifier. Okay. Full wave rectifier. So first we're going to discuss the full wave rectifier using the ideal diode model. Okay, what is the objective of a full wave rectifier? Dun sa half wave rectifier, nakita natin, and this was well pointed out by one of your classmates, Sirik, that during the negative half cycle, hindi nagsusupply ng energy yung source. What we want to be able to do is we want the source to be able to supply energy both during the positive half cycle and the negative half cycle, while still performing the function of rectification. That is, while still converting from AC to DC. Now you can do that if you have two sources. So let's discuss first a full wave rectifier using two sources. So I have two sources, V1 and V2. Okay. V1 and V2. And for the full wave rectifier to work, V1 and V2 must be exactly the same. When I say exactly the same, that means exactly the same frequency, exactly the same amplitude, and exactly the same phase. What do we mean by phase? You're going to study that later on when you study AC circuits. Pero ang ibig lang sabihin ng exactly the same phase, ibig sabihin sabay na sabay siyang umakyat at saka bumaba. No? Hindi nauuna yung isa. In other words, when V1 is at 0, V of 2 is also at 0. When V1 reaches its peak, V2 also reaches its peak. No? So sabay na sabay sila. That's what you mean by exactly the same phase. Okay. Now take a look at the circuit. So during the positive cycles, so remember this is V1 equal to V2. During the positive cycles, okay, what happens? Here, because of V1, current will try to flow in the clockwise direction. And D1, okay, will be on. D1 will be on. Dito, current is also trying to flow in the clockwise direction. Kontra yun sa direction ng arrow ng D2. Okay. So here, current is trying to flow this way. Here, current is also trying to flow this way. No? So notice that here, it's along the direction of the diode arrow. So D1 is on. Here, it is opposite the direction of the diode arrow. So D2 is off. So ang equivalent circuit natin during the positive half cycle, ito lang yung umaandar. No? Yung top source lang yung umaandar. Okay? And V out is equal to V1. So let's draw that. No? V out is equal to V1. So ito yung V out. Okay, now what happens during the negative half cycle? During the negative half cycle, let me use a different color. No? Let me also erase this now. No? During the negative half cycle, current is now trying to flow this way, no? This way, here, and this way, here. So ano nangyayari sa D1? D1 is now off, or that is an open circuit. And D2 is now on. D2 is a short circuit. Okay, but what happens? Where does your current flow? So ito, wala itong current. No? Ito, hindi magfo-flow to. So this will flow. This will go up this way, go down this way, and come back down this way. Let me show that more clearly. So again, current will flow this way. Okay, will go up this way. Will go down this way, and come back down this way. That's what will happen during the negative half cycle. Okay, what is V out? If I do a KVL around this loop, you're going to see that the negative terminal of V2 is connected to the positive terminal of V out. No? And the negative terminal of V out is connected to the positive terminal of V2. In other words, during the negative half cycle, V out is the negative of V2. Right? So magiging itsura ng V out niyan, well, it's here already. No? Magiging itsura ng V out niyan pag ganyan. No? So if you take a look at V out, this is now V out. That is now V out. So that's why you call it a full wave rectifier, because it takes advantage of both the positive cycle and the negative cycle. Okay, if we did the constant voltage drop model for the full wave rectifier, it's similar in the analysis we did for the half-wave rectifier when we did the constant voltage drop model. No? This is the equivalent circuit when V1 is greater than or equal to V sub F, right? Equivalent circuit when V1 is greater than or equal to V sub F, no? You get the open circuit voltage across D1, so parang tinanggal mo yan, tinanggal mo to, kunin mo yung open circuit voltage. When does D1 conduct? D1 conducts when V1 is greater than or equal to V sub F. So we now replace this with its model, which is V sub F. And V out is just V1 minus V sub F. So ito yon. That is V out. On the other hand, this is the equivalent circuit, okay, when V2 is less than or equal to minus V sub F. That is when this diode will conduct. That is when the bottom diode will conduct. And if you do a KVL, if you do a KVL in this loop, you're going to get V out is equal to minus V2 minus V sub F, or the negative of negative of V2, the negative of this. Okay, so that looks like this, minus V sub F. So you're going to get the same curve. So this is now how your output looks like with respect to your input. Are there any questions? Okay, saan ka kukuha ng source nito? No? So this is more just for information. You're not going to learn transformers until the end of this course. In fact, if I'm not mistaken, it's the last topic that you're going to take up. Okay, but V1 and V2 can be generated by a transformer with what we call a center tap secondary. You know, the circuit diagram for that looks like this. You know, a transformer is, you have transformers in your homes. You know? For example, if you have an appliance which is 110 volts and your voltage is 220, then you have what we call a step-down transformer. That's from 220 to 110. No? On the other hand, if you have an appliance that requires more than 220 volts, you have a step-up transformer, for example, from 220 to 440 volts. Okay. If your secondary winding has a center tap, such as this, then you have two voltages which are exactly equal and exactly in phase. So dyan ang gagaling yung input na to, no? Yung V1 at saka V2. So that's just for information. Okay. For information lang yan. No? You're going to learn more about transformers, like I said, at the end of this course. Okay, let's take up what we call a bridge rectifier. So ang problema ng full wave rectifier na pinag-aralan natin just now is dalawa yung sources na kailangan. Ano kung isa lang yung source mo, no? Or ano kung wala kang transformer? Wala kang transformer and you only have one source. Can you do full wave rectification? Well, yes, you can. You employ what is called a bridge rectifier. So you have an arrangement of diodes in this manner. No? There are 4 particular diodes. No? Okay. During the positive cycle, current tends to flow this way. That's how current will tend to flow. No? What will happen when the current reaches here? Will it flow this way or will it flow this way? It's not going to flow this way because that's against the direction of D1. So pagdating dito, ang flow ng current pa ganito. Okay, when it gets to this point, will it flow this way or will it flow this way? Again, it's not going to flow this way because that's against the direction of the arrow. So it's going to go this way. That's how the current will flow. It will go down the load. We'll go back up to this point. Okay, ano mangyayari ngayon when it gets to this point? No? Is it going to flow up or is it going to flow down? Okay, anybody willing to guess? Will it flow up or will it flow down?
The input towards the negative terminal.
Yes, no? It will flow down. It will flow down. The reason it will not flow up is because that's a higher potential. No? Nanggaling na siya ron, no? Your current will always tend to flow from a higher potential to a lower potential. No? So at this point, mas mababa na yung potential niya. No? Hindi naman nagsusupply ng energy yung diode para umakyat uli yung charges. Ano? It cannot go from a lower potential to a higher potential unless you provide energy to the charges or to the electrons. So it will have to go downward here. And so finally, going back to the negative terminal. So that's the direction of current flow during the positive half cycle. So this is the equivalent circuit assuming an ideal diode model, where we just replace now D1 and D4 with the model for a conducting diode, which is a short circuit. And D2 and D4. And we replace D1 and D3 with a model for a non-conducting diode, which is an open circuit. And if you take note, the positive terminal of Vin is connected to the positive terminal of Vout, and the negative terminal of Vin is connected to the negative terminal of Vout. No? Therefore, Vout is just equal to Vin. Okay, during the negative cycles, your current tends to flow in the counterclockwise direction. Okay? So ganun din, ano? Pagdating dito, pupunta siya rito. Okay? Hindi siya pwedeng umakyat dahil kontra yun sa direksyon ng diode arrow natin. Pagdating dito, hindi rin siya pwedeng umakyat dito kasi kontra yun sa diode arrow. So dito siya pupunta, bababa siya rito. Okay? Akyat siya uli ron. Pagdating dito, hindi siya bababa kasi doon na siya nanggaling, no? Ibig sabihin mas mataas yung potential dyan. So ang choice niya, dito na lang siya pwedeng pumunta until it goes back to the positive terminal. So this is now our equivalent circuit. Take note now that itong D1, or sorry, not D1, itong the positive terminal of your source is connected to the negative terminal of your output. And the negative terminal of your source is connected to the positive terminal of your output. In other words, Vout is the negative of Vin. Okay? Pag tinignan mo, parang nakaganyan sila, no? During the positive cycle, magkakabit silang ganyan, no? Ito yung, let's say, ito yung input, ito yung output. Positive cycle, magkakabit na ganyan. During the negative cycle, bumaliktad to. Bumaliktad siya, no? So your output becomes the negative of your input. So parang bumabaliktad siya, no? Positive cycle, negative cycle, positive cycle, negative cycle. Ganun-ganon, no? So this is how your output is going to look like. Positive half cycle, Vout is equal to Vn. Negative half cycle, Vout is equal to negative of Vn. Okay. Your full wave bridge rectifier, you also call that an absolute value circuit. Bakit? No? Because the output is always, pag ideal diode, the output is always the absolute value of the input. In other words, kahit na anong polarity ng input natin, yung polarity ng output natin will always be positive basically. So ang full wave bridge rectifier, ginagamit din yan as a polarity corrector. So sometimes you have maybe electronic devices na pag kinabit mo yung baterya na mali, masisira, ano? May mga device na ganun, ano, na maselang sa polarity ng voltage, ano? That if you make a mistake in connecting the battery the wrong way, masisira yung device natin. So one way the manufacturer can avoid that mistake by the user is by putting a full wave rectifier. Meaning to say, no matter how you connect the battery, the electronic device will always receive the voltage with the correct polarity dahil merong full wave rectifier. Of course, it has some disadvantages. And that disadvantage is what we're going to see now when we consider the full wave rectifier using the constant voltage drop model. Because during the positive cycle, you now replace your diodes with first no. When do D2 and D4 conduct during the positive cycle? D2 and D4 will only conduct when your input voltage is greater than 2 times the forward voltage because you have 2 diodes. For each diode to conduct, the voltage across the diode has to be greater than the forward voltage. And since you have 2 diodes, for the 2 diodes to conduct, your input voltage has to be greater than twice the forward voltage. Okay. So again, no, this is the condition at which your diodes conduct. You replace it with the constant voltage drop model. And what is V out? If I do a KVL, in this loop, V out is V in minus 2 times V sub F. When do D1 and D3 conduct on the other hand? No? D1 and D3 will conduct when your input voltage is less than negative 2 times V sub F. And my V out will be the negative of quantity V in plus 2 times V sub F. No? If I try to do a KVL here, you're going to see that this equation is the resultant output voltage. Okay. And when Vn is greater than minus 2 V sub F and less than 2 V sub F, your diodes are equivalent to open circuits, or V out is equal to 0. So this is how your output is going to look like. This is D2 and D4 conducting. This is D1 and D3 conducting. And then itong area na to, none of the diodes are conducting. So your output is equal to 0. So the disadvantage of a bridge type full wave rectifier, the disadvantage is you have a larger voltage drop. Yung two source full wave rectifier, ang voltage drop natin is only V sub F. Dito ang voltage drop natin will be, or the voltage difference between the output and the input will be 2 times V sub F. Any questions? Any questions?
Sir, if the voltages are large enough to outweigh the voltage drop, the 2VF voltage drop, is there still a reason to use the two source full wave rectifier?
Actually, no. In fact, most of the time, pag tinignan mo yung mga circuits ngayon, usually bridge ang ginagamit, no? Kasi medyo bulky kasi yung transformer eh. To produce a two-source rectifier, you need a transformer and it's rather bulky. So pag tinignan mo yung mga For example, yung mga loob ng charger, no? I don't have one with me right now. But if you take a look at if you open up a charger now, you take a look at the inside, no? There are no more transformers. Actually, ang ginagawa nila is usually yung line voltage mismo, i-rectify na nila using a full wave rectifier, and then they just use a circuit to reduce the voltage. No? It's called a DC to DC converter. But yeah, you're right, no? Pag medyo malaki yung input voltage mo, no, walang masyadong use yung ano, no, yung two input rectifier. But there's another disadvantage of the bridge, ano. I might mention that now. Kasi ang isang advantage nito is, okay, you have a common reference between your input and your output, no? This is a common reference. In other words, you can have a common ground in your system. Okay? But in a bridge rectifier, you don't have a common ground. No? Because yung ground ng output natin at saka yung negative terminal ng input natin are not the same line. So hindi ka pwede magkaroon ng common reference between the input and the output in a full wave bridge rectifier. That's one of the disadvantages. Okay, but maybe I'm getting ahead of myself there, no? Okay, any other questions? Okay, we'll take up no. So tapos na tayo sa rectifier. We'll take up the clipper. Okay, what is a clipper? Okay, a clipper is a circuit that clips the voltage or makes sure the output voltage does not exceed a particular value. Let's see how that works. Okay, so this is a positive clipper circuit. This is my input, and this is my output. Okay, V's of X, itong voltage na to, establishes the maximum value that your output can be. In other words, it establishes the peak, no, value or the maximum value of V out. How does it do that? Okay, when does the diode conduct? No? Again, no, how do we determine whether the diode is conducting or not conducting? Well, let's use method 2 again. No? So you replace it with an open circuit. So open yan. Okay. So this is plus minus V's of D. Okay. When does the diode conduct? The diode will conduct if V's of D is greater than or equal to V's of F. Okay. But in this particular circuit, what is V's of D? No? I don't have any current flowing. Kasi open circuit to, open circuit yan, open circuit din to. I don't have any current flowing. So wala akong voltage drop dito. So V's of D is just V's of in minus V's of X. I can do that using KVL, no? Itong V's of D is just V's of in minus V's of X because I don't have any voltage drop here because there's no current that is flowing. So when does it conduct? It conducts when V in minus V's of X, if it is an ideal diode model, is greater than 0. So yun yung sinasabi natin dito. When V in minus V's of X is greater than or equal to 0, or V in is greater than or equal to V's of X, the diode will conduct. When the diode conducts, it's equivalent to a short circuit. Short circuit yan. So ano value ng V out? Okay? Kahit ano pa man yung voltage dito, ano? The value of V out will just be equal to the value of Vx when your diode is a short circuit. That is why the output is limited now to V's of X. Hindi siya lalampas sa V's of X. On the other hand, when V in minus V's of X is less than 0, remember this is V's of F, no? This is V's of F is equal to 0 dahil ideal yung diode natin, no? When V in minus V's of X is less than 0 or V in is less than V's of X, then yung open circuit natin kanina is valid and your V out is just equal to V in. So here it's V in and then here it's just V in. No? And then here it's just V in. So that is your positive clipper. Question. What will the curve look like if I did not use the ideal diode model? What would it have looked like if I used the constant voltage drop model? Anybody will be willing to guess? What if I had used the constant voltage drop model? In other words, itong V's of F na ngayon hindi equal to 0. So somebody's guessing mag-shift downward yung graph, slightly lower but same. Actually, yeah, you have some, you have some sense of what will happen. But if V's of F is not equal to 0, okay. Sorry about that. If V's of F is not equal to 0, your diode will conduct when V in minus V's of X is greater than or equal to V's of F, or V's of in is equal to Vx plus, or greater than rather, Vx plus V's of F. And your V out will just be Vx plus V's of F. So actually, madadagdagan lang siya rito, no? Where this is Vf. That is what will happen. That's what will happen if it is not the ideal diode model, if it's the constant voltage drop model. So this is your positive clipper. Negative clipper, yung positive clipper, it limits the peak positive value of your output. The negative clipper limits the peak negative value of your output. So notice, binaliktad lang natin yung diode dito. Binaliktad din natin yung reference voltage V's of Y. Okay, so when does your diode conduct? Again, how do you know when your diode is conducting? No? You get the open circuit voltage. So this is my open circuit voltage. I now have here, okay, V's of Y. Notice, baliktad yung polarity ng V's of Y. Baliktad din yung polarity ng diode. So this is V's of D. If I'm going to do a KVL here, okay, I'm going to get V's of D is equal to negative V's of Y minus V's of in. So when will the diode conduct? The diode will conduct when V's of D ideal model is greater than 0. So that means when negative V's of Y minus V's of in is greater than 0, or V's of in is less than negative V's of Y. No? That is when your diode conducts. And when it conducts, your output voltage is equal to negative V's of Y. So ito yon. All other times, it doesn't conduct. No? So here it doesn't conduct. That's why you call it a negative clipper. And I can combine the two. So this establishes the peak positive value that I will allow my output to have. This establishes the peak negative value that I will allow my output to have. Okay. And this is going to be my output. No? It will clip at v of x. It will also clip at minus v of y. Clip here, clip there. Okay. And that's my last slide. So that is all we're going to discuss with respect to practical diode circuits. There are still multiple or many numerous diode circuits that are available. These are the two most common that you can already understand how it operates with what you know. But most of the others requires an understanding of capacitors. No? When after you've studied capacitors, then there are still a lot more practical diode circuits that you'll take up later on. So are there any questions with regard to what we took up today? Any questions? So again, no, yung pre-recorded lecture nito, I actually already published it dun sa study guide. So this is a repeat of that. Hopefully, I was able to give you a little bit more insight than just the pre-recorded lecture. I hope you've already tried to solve the practice problem set 1. After this, you try to solve now the practice problem set 2. And that should make you ready to take the quiz. And at the same time, the problem set for diodes has already been released. You can also already take a look at that and try to solve that. No, we had a discussion among the handlers. We decided to give more leeway in terms of submission time. So like the quiz is now going to be valid for 1 week, and the problem sets are going to be released a little bit earlier. So we used to release the problem set pag Friday. Ngayon, i-release namin ng Wednesday. But we're going to give you 2 weeks. But don't wait until the last minute kasi mag-accumulate yan sa inyo, no? If you wait until the last minute, then mag-overlap yung mga requirements ninyo from week to week. The reason why we wanted to put strict deadlines before was to force you to perform the requirement before the next week where there will be a new requirement. Now you have a little bit more flexibility, but you should also be a little bit more responsible and not allow your requirements to overlap. So as usual, if I will stay on, I'm willing to answer any questions until the last person drops off. No? Otherwise, that's all for today. Thank you.